Hi, so this video discusses the stacks and their numerous applications in computer science. This chapter examines the various stack operations as well as implementation of stacks as arrays and linked lists. So in this chapter, we have the following objectives: learn about stacks, examine the various stack operations, learn how to implement a stack as an array, and also implement a stack as a linked list, and discover stack applications. Now, what is a stack? It is a list of homogeneous elements wherein addition and deletion of elements occurs only at one end. That end is called the top of the stack. So this is the last in, first out data structure in which the elements are added and removed from the top. And this will be used to implement method calls. You can also use stacks to convert recursive algorithm, especially the nut-tail recursive into non-recursive algorithms. Now, the stack insertion operation is usually called push, and similarly, because the top item can be retrieved and or removed from the stack, we can perform the um, operation top to retrieve the top element of the stack, and the operation pop to remove the top element from the stack. So this figure shows the various types of stacks. We have stack of coins, stack of trays, stack of boxes, stack of books, wherein you can add new book to the top of applied math. Okay, and also you can retrieve automatically the item at the top. So at this time, the stack of books, we have the top item, the applied math. Now, if you want to remove an item from the stack, we have to remove first the top book, which is the applied math. Now, okay, so this stack implements the LIFO data structure. So the top element of stack is last element to be added to the stack. And elements are added and removed from one top, from one end that is called a top. So in this case, item added last are removed first since it will be put on the top. Okay, so this figure shows an empty stack. Okay, and we have the following items to be added to the top. Okay, and then, so the next figure will show on how to add these items to our empty stack. Say we need to push box A. So box A will be pushed on our stack. Next item to be pushed is B. So B will be pushed on top of A. Next is to push box C. So box C will be put on top of box B. Now to retrieve the top element, so we have here box C. Now push another item we have here. We have to put box D on top of the element or on top of our stacks. Now to remove an item from the stack, so we have the pop. Okay, after popping the element, so we have box C at which is at the top of our stack. Now we have here the stack operations. First is initialize stack. This initializes the stack to an empty state. All right. And for the operation is empty stack, this checks whether the stack is empty Now, if the stack is empty, it returns true, otherwise it returns false. Another operation is full stack. This will check whether the stack is full. If the stack is full, so it will return true, otherwise it will return false. Now another operation is push. It will add a new element to the top of the stack. The input consists of the stack and the new element. So before inserting an item to the stack, we need to evaluate the stack that must be exist and must not be full. And the top operation returns the top element of the stack. And before returning the top element of the stack, we have to make sure that the stack must exist and must not be empty. Another operation is the pop. This will remove the top element of the stack. Before removing an element from the stack, we have to make sure that the stack is not empty and must exist. Now, so this is an example of a stack wherein the stack size is initialized to 100 and the stack is not empty since there are 4 items in the stack. So the stack top is 4. So because there are 4 items on the stack. Now we have here, this figure shows an empty stack in which we have already, well, we have also the stack size that is maximized to 100, or the maximum size of the stack is 100. It is empty, so stack top is 0. Now, so this table shows the time complexity of operations of class stack type. We have here the method at column 1. Okay, and the first method is empty stack. So this is O of 1, time complexity, it's constant because you don't need to traverse the elements in the stack just to check if the stack is empty. And same as with is full. And initialized stack is O of n is, so it is linear since we have to initialize the value of all the elements in the stack. For the constructors, creating a constructor, it is constant. Retrieving the top element is also constant. It's O of 1. Push is O of 1 because adding a new element requires only to push to add a new item on the stack. For pop also, the time complexity is O of 1 since we don't need to traverse the elements in the stack. For copy, like copying the first stack to another stack, needs the linear time complexity because we need to transfer or copy one by one. And also same as with the copy stack and the copy constructor, they are also O of n. Now we have here also, you can also implement the stack as a linked list. This figure shows an empty linked stack, okay, in which we have the reference variable wherein this contains the first or the address of the top element. Okay, so top element is easily retrieved so through the stack top. And the second figure shows the non-empty linked stack, in which the stack top is a reference variable that has the address of the top element C. Okay, and top element C, okay, is a node that is linked to another node B, and this node B is uh, an element of the stack wherein it is connected to node A. Okay. And if ever we are going to push an item to our stack, we need to check if the stack is existing and is not full. So this is the stack before um, pushing a new item to the stack or before the pushing operation. So we have here stack top that is pointing to the top element C. And now we are going to add a new element, which is D. So first we need to create a new node that is pointing to that is holding the item. Okay, in this case, the item or the relevant info is character, so it has a value D. And after that, the new node dot next will point to the stack top, which is C. And since every pop and push, we have to update the value, the pointer of stack top. So at this time, we need to update the value of or the pointer of stack top that is um, pointing to node D. Now, so in this case, they are connected to our stack elements. So we have already okay, E, C, B, and A. Now, for the pop operations in stack linked, we have here. So before the pop operation, we have the items C, B, and A. So they are the nodes that which are the content of our stack linked. Now, so since we need to pop and we need to pop something from the stack, so whatever the top element will be removed. All we need to do is to update the pointer of stack top that is pointing to the next element. So instead, from node C, our stack top must be altered and let it point to the next element. So you can make it stack top is equal to stack top dot link. And some applications of stacks includes the postfix expression calculator. Like this will be applied to the prefix or the polish notation, and also the suffix or postfix or the reverse polish notation. Okay. So this table shows the infix expressions and their equivalent postfix expression. And this postfix expression can be fed to stack. Okay. That is, okay, in our stack, we need to push 6. Then, after pushing 6, we need to push 3. So at this time, the items in our stack are 3 and 6. Now, we have the operation plus. Okay. Since we have the operation plus, okay, we need to pop 2 items from the stack and perform the operation. All right. So the result of which will be pushed back to the stack. And take note, we have to choose the operand 1 and operand 2. Operand 1 is 6 and operand 2 is 9. This is very necessary if ever you will be using operation, subtraction, and division. Okay. And then, so after pushing the result of 6 plus 3, which is 9, we have another item 2. So item 2 will be pushed to our stack. So the content of our stack now are 2 and 9, in which the operand 1 is 9 and the operand 2 is 2. And next we have the operator multiplication. So since our next item is multiplication, we need to pop something or pop two items from the stack, that is pop 2 and pop 9, then perform the operation. So that is 9 times 2 is 18. So the result or the product of 9 and 2 will be pushed back to the stack. Okay. And so 18 is now in the stack. And then we need to retrieve the result on our stack. So we have here 18. So after retrieving and popping the element, our stack now is in empty state. Okay. So we can have also the temporary variable that will be used for traversing the elements or traversing the nodes in our stack linked. Say for example, we will be using the current reference variable. Okay. And this will be used repeatedly for pushing an item to our stack linked. And of course, we need to update our current, that is current is equal to current dot link. So this summarizes our stack with wherein you can implement the stack as an array and stack as a linked list. So the next video will show you the demonstration in creating a stack as an array. Thank you.